All right, let's start. Welcome to today's class. Today we are going to talk about a new section about the data visualization. We will go through the different types of plots and figures and show how we can use them. So before that, we briefly talk about why we need the visualization. What can we get from the visualization result? So first we can use it for the EDA, the exploratory data analysis, so that we can form some hypotheses or the guiding, or it can guide the further analysis. So it can provide some insights for the EDA. And also some well-designed visualization can communicate the complex data inside more effectively than the text or the original raw data. And also data visualization can be should be constructed with the intention of presenting the data accurately and without bias. And at last, the visualization can be important for some stakeholders who do not have the deep technical or understanding of the original data, such as they don't have such background, so that when using the visualized data, they can get more insight and understand the data easily. So let's see an example. So for example, we have some data and we have about some students' homework. And so for the results, we may see if we just check the number, the results, we will see that for this homework, the average score for the homework is about 50%. And so this is this is the mean value for this data. But if we draw this data in a figure, in a graph, we will see the result like this. So in fact, the results are very different with what we thought. So many people are 0, and other students will get a high score. So that in such case, only using some statistical data like the mean value or something may not present the result well, so that we can using the figure could be better. And when we are trying to create a visual, so we have some best practice, and the most important thing is we want to show the result. We want to make it less. So when you have the less is more effective, it's more attractive and more impactful. So we hope to simplify the design. We do not hope to use some complex elements or some colors or many colors. And we hope we need to focus on the data itself, some data points, and only highlight the most important data points or the trends. And we don't have to distract the users. We don't have to provide so many informations to users. We don't have to overwhelm them. And we hope to use limited color and the text, and also design some white space in the mind. So here is an example. So we show the same result. We show the same data in different figures. So for the left figure, we can get some data and results, and it is in fact a 3D pie chart. But from the left figure, we can see there are some, although it is more engaging and it looks like better, but in fact it provides it used many different colors, so this can distract users, and also for the result, such as for the ribs and the harms, if we want to compare them from the figure, in fact, you cannot compare them. So like this and this. So we know that we may see that it is 14 and 12 percentage, but if we want to compare them, it would be difficult. But if we change it to the red figure, we just change it to a very simple bar plot. We can see that although it is not engaging like the left figure, but it is easier to understand. It just provides the most important thing. We see that which one has the highest percentage, and also it can focus users' attention on the data instead of the color. We only have one color, And at last, we show the total percentage here, 100%. We show it in a separate element instead of a pie chart, so that this will still emphasize that the sum of this result will be 100%. So, and then for this figure, we can see it could be more clear, and for users, they are easier for them to get the most important information. So here are some different types of visualizations that we can use for. So for example, we can use, we have the distribution, use a visualization for the distribution. So how the variables in the data set distribute over a range of possible values. So for example, we can use the histogram or the box plot to show the distribution of variable. Some visualization to present the relationship, how the values of multiple variables in a data set relate. So such as the scatter plot or the bubble chart, we will talk about them later. Or the composition, so how the data set breaks down into subgroups. So this can help us to understanding like the proportion or the percentage or the contribution of this different categories. And at last, we can compare the different groups of sites for the comparison. So how the trends in multiple variables or data sets compare. We can use like the bar chart or the line chart to do the for the comparison. And we will mainly talk about, we will mainly use the following two libraries. One is the Matplotlib, which is we can call it as a low-level library that can produce a wide range of plots. And but if you need to create some complex plot visualizations, it needs more code. And on the other hand, the Seaborn, it is a library that is on the top of the Matplotlib, and it is designed to draw some more complex figures. So for the Matplotlib, on their website, they said that Matplotlib is a Python 2D plotting library, which produces publication quality figures in variety of the hard copy formats and interactive environments across platforms. So that normally for the academic papers, we can also directly use the generated figures from the Matplotlib. You can directly download it and insert it into your papers. So that is very convenient for us. And it is one essential tool that can help you to draw some figures. And yeah, another thing is there's no best visualization libraries for the Python, so that you can try different libraries. And also for the similar, like for the same library like the Matplotlib, we are going to talk about different plots and different tools, so that you can also try something else in addition to the things that we introduce on the class. Let's start with an example, and we will introduce different figures using this example. And for the example, we have a data set, and the data set contains the annual data on the flow of the international immigrants as recorded by the countries of the destination. And this data will present the inflows and the outflows according to the place of the citizenship. And in the current version, there are 55 countries, but we will only focus on the Canada from the 1980 to 2013. So we will only check about the data related to the Canada. And yeah, so we can first download the data from a website and read it, and then import the libraries. So as we said, we will use the Matplotlib. This is the library that we will use in this example. And in this example, we will also import another function called the Matplotlib Python plot. So we will import it as the PLT. So this is a very useful function or tool that we can use. And this function, using this function, we can make some changes to the figure, such as create a figure or create a plotting area in the figure, or plot some lines or add some nodes in this figure, so that this is a very useful, basic and useful function. And using this, we can draw some basic figures. So such as we start with the line plots, which should be the most the basic one. So a line chart or the line plot is a type of plot which displays information as a series of the data points. So they are called the marker connected by straight line segments. So that we will have a figure like this, and it is a basic type of the chart and in many fields. And using this line, when you have a continuous data set, and so in the data set we just imported, we can directly draw such a figure using this command. So we first select just a random country like the Haiti, and then we read the data. After we read the data about it for every year, how many immigrants from this country to the Canada, and then we can directly call a function we can directly call the pandas plot function to draw this figure. So for this is convenient. So here the Haiti is still in the pandas library. We are not using the matplotlib library. We are still using the panda library. But for the panda library, it provides such a function to directly plot the figure. And when it plots the figure, it will treat the year as the x-axis and treat the population as the y-axis. And then we will have this figure. This figure just shows the trend for this country, and we can see that it has a spec here, and so for the previous figure, we can see that it just have such a figure, and there's nothing else about such as the title, what is the x-axis, and what is the y-axis. So that's a limitation for the pandas plot function, so that we can use the function from the matplotlib, the plot, to add the titles or the x label or the y label for our figure. So that we add the as a title as the immigration from the Haiti, and the Y label as number of immigrants, and the X label as years. So that we will have this we will have the labels for each axis, and then we show the result. So this time we will have a better figure. And also before that, we also transfer the type of the year. Previously, the type of year is in fact the string. So like the 2010, it is a string value, and we transfer it into the int value, so that now it is more reasonable. Yeah. And we can, from the figure, we can see that there is a spike here in 2010. And if we observe such things in a figure, we can try to add some annotation, and then we can let others know what we are focusing on. And using just a few lines of code, we can visualize this spike in this figure. So we still define all the things, and then we annotate here. We annotate the text in specific location, position, and here we see the 2000 and 6000. 2000 means it is the year. So here we will write the text as here the 2000, and the 6000 is the population, so immigration, so that this text will appear in the 2000, 6000 here, so that this will be the position of this text. And this is for the if the year is the int value. So we can note it as the 2000. If it is not an int value, it's a string value. So we can also do the similar thing. So if we know that 2000 year is like the 20th year, so that we can use here, we can change it to 20th, and then it can still print the text in this position. So this is previously we showed one country, and if we want to, we can also do the same thing for some other countries. So if we directly call the pandas library the plot, and when we read after we reading the data, we will get this figure. So if you check this figure, you can see that the reason is the pandas plot function. It treats the x and the y labels incorrectly. It treats the country as the x-axis and it treats the year as a y-axis. So this is not correct. So this is because it automatically do this, but it doesn't know what is x value and what is y value, so that it will draw this figure. So this is not what we want. It doesn't look good. So that we need to fix it. We can slightly change it. So for the original data, it is in a table like this, and because now now the function treat the data wrongly, so that we can do the transpose for the table. So that after the transpose, we will get the correct value for the function, and then when we use the function to draw the figure, we can get the correct figure. So now in the figure, we will get the thing that we want, and we can observe that for the last more than 20 years, for the country like the China and the India, they have similar immigration trends, and this is what we want and what we get from this figure. So we can also add more lines to the figure. So you can do that, but it is recommended that do not show more than 5 or 10 lines in one single graph. And because if you have more lines, it will be difficult to interpret it. And also it will be difficult for others to understand what you want to show in the figure. So so this is one example in my paper. So this is one figure. So in this figure, I draw 7 lines. You can see that if I don't explain it, you don't know what I want to say. But if we add some annotation, this will be better. So for example, I annotate each spec on this figure so that you know for this figure what I want to say. I want to explain each of these specs to you, so that it will be more clear. So that this is only for 7 lines. So if you have like 10 lines, it would be very complex, and it will be also difficult to explain. So do not use too many lines, and I think five lines should be good. Yeah. So this is for the line plots, and next let's talk about the area plot, which is also known as the area chart or the area graph. And it is commonly used to represent the accumulated totals using numbers or the percentage over time. And we can consider it as it is based on the line plot, and then we doing something else. So for the area plot, they are stacked by default, and to produce such a stacked area plot, we require that each column must be either all positive or negative, or all negative values. So if it is not a number, it will be the value will be 0. And if we want to produce an unstacked plot, we need to define it here. So in the function, we first define the count as the area, so that we know the function know what figure we want to draw, and then we define the stacked this one as false, so that it will be an unstacked plot. And then for other things, we don't change them, still show the result. and we will get this figure. It is an area plot and it is unstacked. So that yeah, we can show the trend of different countries in the figure, and we can also slightly change it. You can see, you can compare them. So we can also slightly change the transparency of this figure. So by default, the transparency of the figure will be 0.5, like this figure, and we can slightly change it to like a 0.225, so that it will be like this. So this is what we changed here. We can use we can change the alpha from 0.5 to 0.25, so that it can be, sometimes it can be more clear. And so in addition to the plot, we can also define some variables called the axis. We can first define it, and instead of you define all the things in your current plot, you will store all the data in a variable and then use this variable to draw this figure. And so here you can use this variable and set the title, set the label, X label or Y label. This is similar to the previous one, but later you will see that using such thing would be much helpful when you want to draw such as subplots. So if you have multiple subplots in one plot, this type of variable axis will be very helpful. And yeah, so we will see them later. And yeah, so still using this variable, we can still draw such an area plot. And this time it is a stacked plot. So we can see that for all the value for all the countries, the results are accumulated, so that we can get a overview of all the population, all the immigrations for these 5 countries, instead of checking them individually. All right, next figure is a histogram, and it is a way to visualize how the one-dimensional data is distributed across certain values, and how it works. Before we draw the figure, we need to define some bins. So so that, for example, for the data, you need to define different bins and then calculate how many data is in these bins. So this is what you need to do before you draw this figure. And so in such case, the y-axis will be the frequency or the number of the data point in this bin, and the x-axis will be the different bins. And we can also change the size of bins, like these 3 figures. If you set a different bins size, and then you can get a different results, so that you can, yeah, this depends on what you want. And from the figure result, we can get some insights about the data. So for example, what is the center of this data? So like in the third figure, we can see the center of data is here. What is the spread of the data? What is the mix? What is the minimal value and what is the max value? And what is the presence of the outliers? Sometimes you can find them. And what is the presence of the multiple modes in the data? And this could provide more information in this figure. And so let's see for in our data set what result we can get. So we first use let's see which country, I forgot. Yeah, we first we want to get what is the frequency distribution of the numbers, or we can see the populations from the various countries to the Canada in 2013. So if we do this by default, we will have 10 bins. And then for each bins, there will be some countries, a different number of countries. And we draw the figure, and from the figure, we can see that most of the countries, they will contribute, they will be between from the 0 to like 3,000 immigrants. So this is for most of the countries. And for like 10 countries, they contribute between the 3,000 to 6,000. And then there are some other very few countries, they contribute much more immigrants. And this is what we can see from the figure. You may find that for this figure, in fact, the x-axis label, it does not match the bin size. So you can see that this is a bin size and this is a label. So they are not aligned, so that we can slightly change it, and we can define the x ticks to as the bin edges, so that now they will be aligned. So this figure will looks better. So this is for previously it is only for one country, and we can also do this for multiple country. But for when we draw multiple countries result in the same figure, there will be some issue. So you can see that here we draw the result for 3 countries, and some of them their results will be hidden by other data. So this will not look good, so that we can slightly change it. So we can make some modification and improve the results. So such as we first increase the bin size from 10 bins to 15 bins. And we defined here, so for the histogram figure, we set it as 15. And then we changed the transparency to 16%. Here, the alpha equals to 0.6. So this setting will make the figure more clear. We can see the data that is hidden by other countries. And we also label the axis. And at last, we changed some colors. So we slightly changed them to some other colors, so that makes the figure more beautiful. So that after making these changes, we will get this figure. And from this figure, we can see some results more clear, and we can see the distribution for each country. So also, if we don't want to, we don't have the plot to overlap each other like this. So here there are some overlap. So we can still stack them using the stacked parameters. So that in the result, we can see they will not overlap each other, and we will get the sum of them. And we just, in addition, we also, in this figure, we also slightly changed the minimal and the maximal x-axis value, so that for the left part and the right part, we have some white space, so that it makes more the result more clear. And yeah, so this is the result for some other countries. We just change the countries, so we can apply the same method to different countries, depends on what you want. And this is for the histogram figure. And next is bar charts. It can represent the data, where the length of the bars represents the magnitude or the size of the feature or the variable. So this is also very basic figure. And so it is usually I represent the numerical or the categorical variables group in the intervals. And we can draw such a figure using like which country is it? We use the country as the Iceland country, and we print out we generate a figure to show what is the immigrants number for each year, and we will get this number. We will get this figure. So here the x-axis is a year, and the y-axis is the immigration number, and we draw this figure in the vertical, so that we can analyze the time series data. The x-axis will be the time, so that this is very straightforward. We can see the trend for each year. And yeah, we just change the kind of the figure to the bar, so that we can get this bar figure. And from this figure, we have some, we can still do the similar thing. We have the observation that there will be a spike here, so that if we want to annotate it, we can doing something such as adding some tables or adding an arrow here. So if we want to do this, we need to have more settings showing this area. So for the arrow, what is the start point, what is the end point, and what is the rotation, and for the text, what are them, so that we can define different things, and such as XY or the XY like could be the position and something like the and some others like the arrow type here. You can define the arrow type and the color and something else. And similar, you can define the text and about all the things about the text so that you can label such thing. And this is for a vertical figure. Sometimes we may also have to draw data the horizontally so that we can slightly change it. We change the data we can change the can to the bar h. So here the h means it is a different rotation, and then in this for this one we can get the we can draw a figure in the different rotation, and this could be useful for the sometimes the label could be very long, so like this. So here the United Kingdom of so the label is very long so that you don't have to show the figure in the vertical, so that you can change it to this one, and yeah, this is for the bar chart. And next will be the pie chart, also a very commonly used chart in the business or some companies. And it will display the numerical proportions by dividing a circle into different slices. And if we want to define such a figure, we can still use kind equals to the pi, and then define define the data. So here we define the data like show the result in percentage, and where would the graph start, and some other settings. Then we will get the right figure. So for this figure, we can see that some of the annotations, the results, they are overlapped, so that we cannot see them clear. So that we can make some modification to improve this. So for example, we remove the so for example, we add some settings. We move the percentage, the result number from the inside of the pie, from outside of the pie, or we pass and change different colors and doing something else, and then we can get a figure like this. So you see, we show the result outside of the pie, and then for the result that have the lowest percentage, we can push the results to the outside, so that others know you want to this is what you want to emphasize. And also we changed some colors so that the results could be better. So for the pie chart, it is also a very commonly used chart. And next one is a box plot. So it is a way to statistically representing the distribution of the data through the following 5 main dimensions. So we have the minimum value here. So it is the smallest number in the data set. We need to exclude the outliers. So that for the outliers, we will discuss them separately, like this part. And second is first quarter, and then the medium, the third quarter, and the maximum value. So this is all the things we can get from a box plot. We can get this information so that it will be very clear for us to get the statistical data. And if we draw a figure like the for example, for a country, we get what is the immigration number for all the years, which year, which is a minimal immigration number and which is a maximum immigration number. We can draw all the data in this one figure. And for this figure, we can easily get some information, like the minimal value would be 200 here, and the maximum number, maximum immigration value would be 1,300, and the median number will be here, like the 900. So this will be some very straightforward information we can get. And for this figure, we can use it for comparison. So for example, in previous figures, we show the immigration number between the China and India. Their trend is similar, but we cannot get more difference. So if we use this box plot to draw the results about these two countries, we can get different things. So for example, the left part is China, right part is India. We can see that although their mean value here, this line, they are similar, but for some other information, they are pretty different. So for example, for the China, their immigration population range is more spread than the India. And also the maximum value for the China is much more than the India's maximum value. And this is some, when we have the so the box plot, it can be useful for the comparison. You have multiple data, and then you want to get more insights about their difference. You can use this. And similarly, we can draw the figure. We can draw the figure in different rotation, and then you can do this. But in fact, this is not very commonly used. So in most of the cases, we will only use the result in vertical. But this can be useful when the label is very long. You can put it like this. So so sometimes we also want to draw multiple plots in the same figure. So for example, we may want to perform a side-by-side comparison of the box with line plot of China and India's immigration. And then to visualize the multiple plots together, we can create a scene like this. So we can first draw a figure and then divide the figure into multiple subplots. And each subplot will contain a plot. So with these subplots, we can get more information such as compare them. And so if we want to do this, we just discussed that we can define different variables like the AX, and each AX will be will represent one subplot. Here the AX0 will be the first subplot, and the AX1 will be the second subplot. And then for each subplot, you can define all the things for this variable, such as the title, the x-axis, y label, all the size of each subplot. And then we can put different figures into one figure, so such as this. So now this is not two figures, this is only one figure, and it includes two subfigures, so we can compare them. Yeah, so let's come back to the box plots. And so for the box plots, we can draw more figures like or we can have some further analysis using the plot. So for example, we want to create such a box plot to visualize the distribution of the top 15 countries grouped by the different decades, like the 1980, 1990, and 2000. So now we can do something else. So for doing this, we need to calculate the data, create a new data frame, and then sum the result from different countries, and then merge them. So if we yeah, if we can first doing some calculation, and then we will get this table. So this table just shows the top 5 countries, and we can get the result that for each country, what is the immigration number for different decades, 1980, 1990, and 2000. And then we can draw this figure based on the decades. And for this decade, for this, now we are not using the different years, we are using different decades, and we can have a higher level of overview about the how the immigration number changed. And another thing we can notice in this graph is we can see that here are some outliers. So like this point, and these 2 points. So so for these outliers, how could we how could we identify them? How could we define that? So we have for the box plot, we have a definition that for the data points that is larger than the third quarter by at least 1.5 times the inter-quarter range or the IQR. IQR, it means we use the third quarter to minus the first quarter. So it is, in fact, this range, the length of this box. And so if the outlier it minus the third quarter, it is greater than 1.5 times this IQR, we will treat it as an outlier. And similar for the data that are less than the Q1, we will also use this to get the outlier. And so this is how we can how this method will detect the outlier. It is very straightforward instead of using some complex algorithms. So because it is it mainly focuses on the visualization instead of the analysis. And yeah, next is a scatter plot. So it is in fact it is similar to the line plot, right? So the only difference is they are not connected. So now we only have some individual points, and they are just showing in this figure. So we do not connect them, but we can still see the trend for this data. So similar to the line plot. So and also we can use some analysis tool like the regression to get to mathematically calculate this relationship between the 2 variables. So the main difference between it and the line plot is it is focusing on the relationship between the variables instead of the trend. So this is they have different focus. And if we draw the data in our from our data set, we can create a figure like this. So still the x for the x and y values, they are still same. And then we can, from the result, we can see for this one, we have some, we can see the trend is increasing for this country. So if we compare these 2 figures, the scatter plot and the line plot, so we can see that they can both show the trend of the data, but here are some difference. So for example, for the red figure, so we have so many data points, and it is not related to the time. The left figure is about the time, so that we can connect them and see the trend. But for the right figure, it is just some data points. What we want to find is their relationship, and also we cannot connect all the data points because they are too complex. So that for the left figure, the line chart, it is always it is better to use for the data points with some continuous line and to show the trend. And for the right figure, it displays some individual data points. And for these data points, we focus on the distribution and their relationship. And let's see. So we can also mathematically analyze the data using the regression line. Like this is what we learned. We define such a model and feed the data using feed the model using the data, and then we will get such a regression line. And we can draw this line using some. Then we can draw this line. We will have such a regression line for this data. So this is how we can do some mathematical analysis for this result, for this data, and for the scatter plots. Let's see. Okay, the last one. This should be the last one, right? Let me see. Sorry. Yeah, the last one is a bubble plot. It shows. Previously we only have two variables x and y. So now we have the third one. We can use the size of the bubble to show the third variable. And in this example, we can show the third variable as a weight, and the weight is normalized of the population, and then we can get this figure. So for this figure, we can see in different years, the bubble have different size, and this size will show in fact, it also shows the population for each year, and this is but when we use it, we can use it to show the third variable instead of the previous two variables. So this is for the bubble plots, and yeah, this is the end of this class. So we introduced some basic plots that we may use, and you can select them based on your necessity. Okay, this is the end of this.